When you plug in a USB drive into your system, do you expect it to automatically be recognized and mounted? I know I do. There is a lot that goes into this process, but it is made easier with the Linux Device Manager, Udev. How does it work? I'm glad you asked. This is B from Talk Tech, and today I'm going to explain to you all about how the Linux Device Manager Udev works. Stick around. I have a favor to ask. If you like this type of video and want to see more content like it, make sure to subscribe and hit the bell button for notifications. Also, don't forget to give this video a like if you like it. Let me know what you liked, didn't like, or if you have any comments, questions, concerns, or emotional outbursts down in the comments below. And lastly, stick around all the way to the end to get the most out of this video. Let's do this thing. All right, so I'm going to go ahead and shrink my face down here just so we can go ahead and visit my Linux laptop that's off to the side over here. All right, so Udev is actually a daemon. So it's just like any other service that's on the system. And it's used for managing device nodes dynamically and managing device files in the /udev directory, which is going to be ls-tech dev. These are all device files right here. These are a bit different than the text files, PDF files, things like that. Let's clear this out. All right, now, so it is a daemon officially, and it actually goes by the name of systemd tech udevd. So let's actually go ahead and look at this daemon. Systemctl systemd udevd. Oh, let's go ahead and actually add in status here. Forgot about that. We're just going to look at the status of it. And we can actually see that here it's running. All right, so we know that that's running, and this is going to be the primary device manager on most modern Linux distributions. All right, now one big thing that this does, in addition to handling, devices, is it actually handles persistent naming for devices. That's why when we see, if we run let's go ahead and do this. Let's clear this out. Oops. Why is this not quitting? There we go. All right, if we just run the lsblk command, we can see here that this particular drive currently only has a single drive on it, which is going to be this one right here. This is NVMe drive. So we can see that this name right here is the name that it's getting, and it keeps those names persistent and consistent so that, certain types of drives are going to be getting a certain designation compared to other drives. Like for this one, it's NVMe 0 and 1. If this were an actual disk, it would be SDA1. I'm sorry, SDA, and then there would be SDA1, SDA2, and things like that. And we'll see that here in just a minute once we actually look at a storage device. So, all right, now there's four components. There's four components to Udev. So the kernel generates an event for a hardware changes. Udevd listens for events from the kernel. Udev rules are configuration files specifying how to handle events when they happen. And Udev database stores information about currently active devices. And the actual device location for the Udev database is going to be run Udev data. Oops. And here we go. We've got all these different files right here. All right, we're not going to get into any more about the database, but this is the database right here. All right, now the actual Udev process. So what's going to happen, the kernel is going to generate an event, which detects, a device being added or removed. Let's clear this out. All right, then the Udev daemon listens for these events on what's called a netlink socket from the kernel. A netlink socket is a socket used for inter-process communication between the kernel and user space processes. This is primarily miscellaneous networking information. Configuration files, as we mentioned just briefly a second ago, are typically going to be located at etc udev oops There we go. They're going to be in this location, or the other place that they can be is going to be, they're going to be user lib udev, and there we go. It would be in that location right there. One of the primary ones for udev is going to be this one right here, the udev conf file. All right, now it processes events based on rule, and I'm sorry, this is the configuration file for udev. So, and all that good stuff. Now, as far as rules for the way that it actually handles different events, those are going to be housed in a slightly different location. So those are going to be either in etc udev rules.d. I don't know why I can't type those. And there's this one right here. There's just that file right there. They could also be in user lib udev rules right there, or they can be in run /udev rules.d. And one of the things that you'll probably notice here is that each one of them has this rules.d in its actual path. So just that's going to kind of be an indicator that these are going to be the actual location of the rules files. Now, and then depending on the rules, udevd creates or removes the device node from the /dev file, which is what we looked at earlier. Now, based on the rules, it will take additional actions. We're not going to discuss rules in depth in this video, but do let me know if that's something that you want covered. But just know that you can customize them to your heart's content. So there's a lot that can be done there. And let me just kind of show you a brief little illustration. So here's where it's actually the events being communicated to the udevd daemon, and then the UD event process matches event rules, creates and moves device files, and then this right here programs another file, load the right module, notify user space programs, the GUI, whatever application you're interacting with, and things like that. So let's go ahead and actually talk about a couple of udev commands. Now, the primary one for monitoring the udev daemon is going to be udev admin or adm monitor, and it's going to go ahead and monitor it. So what I'm going to do is I'm going to step over here off the screen, and I'm going to plug in a USB drive into this, and boom, look at all that. And see, it's recognizing, it's doing all of its communication and things like that. It's quite a bit that happens when you plug in these devices. So that's what it's actually going to look like. Now, let's go ahead and close out of there. Let's clear this out. We're going to go to lsblk. And we can see here, this goes back to that naming scheme. So here's that dev SDA, and then the dev SDA1, because this is a partition on this actual disk here. This is actually a Fedora KDE install USB. So that's what that one is. Now, if you want to get information on a specific device, what you can do is you can do udev admin, and then you're going to type in info dev SDA. In this particular case, this is going to go ahead and give us more information about that device. We can go ahead and sit here and click through this like less, and it gives us all this stuff about it. You could also do, also do it a little bit more specifically and look at the actual specific partition. And this is going to give you information about that particular partition. So yeah, udev is one of those things that's really important. And in your Linux experience, you'll probably never think about it. This is a good thing though, because if you're thinking about it, it's probably not working correctly. That's kind of how this thing works, and it's also another one of those things in Linux that may seem intimidating at first, but it's pretty easy to understand once you get yourself familiar with it. I feel like this video's kind of presented it pretty straightforward. Now, make sure you check out this other video from my channel. Remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.